Okay, pull out a piece of paper. Is this on? Can't tell. Okay. On a piece of paper, first I want you to just look at a couple similar problems. And this is the 8.3 washer and disc method. Okay, so we have Oh, that must be an equation, but I guess it doesn't. I guess that's y equal. Okay. Okay, a pyramid 3 meters high has triangle sides. The pyramid has the pyramids, right? There's triangle-based pyramid and there's square-based pyramid. Okay, and this one is a square base that has 3 meters on each side. So we have a pyramid 3 meters high with congruent triangular sides and a square base that is 3 meters on each side. Each cross-section of the pyramid part of the base is a square. What's a cross-section? I get down my water bottle here, and I cut a cross-section. What would I get? Karate chop it, and what shape do I get? A circle. Okay, if I cut this, square. So you have to cut it. Magic. Square, right? So that's the cross section. I give you slices of loaf of bread. Each of those slices are representative of a cross section. So I know I get a square. Okay, we're going to find the volume of the pyramid. So this is on an axis. And so the pyramid is 3 meters high. So I'm going to do it from 0 to 3. That's going to be their height. And each square has a square base of 3 meters on each side. So if I'm bringing my pyramid out, how tall is this length? Oops, that wasn't quite congruent. How tall is it from the middle of the base to the edge? 1.5, yep. And this goes down to negative 1.5, right? But in total, it's 3, right? So what this really is a line that has been rotated around the x-axis. And we get, when we rotate it around the x-axis, we get a three-dimensional shape. You look at your books. We're looking up to 404. The book has it way better than I can draw it. 404. What kind of like a pyramid? Okay. If we cut this guy in cross sections, what shape should we get? Square. I even told you in the directions there. This is for example 1. So we get a bunch of squares. Now, depending where you are on the pyramid, your squares are either larger or smaller. But way out here, it's a 3 by 3, right? So if you're way down here, It's a little guy. Cross-section's area is always changing. Okay? So essentially there are about 4 steps to find the volume. So on your paper, let's write down 4 steps. And it says there in the block on the top of page 404. What's the first step? What's the first step in that kind of brownish box? Yeah. Sketch the solid and cross-section. You want to know what type of shape you're finding, because in this case, it's a square, but other cases, like the water bottle here, your cross-section was a circle. Okay, step 2. What's step 2 in that brown box? And what is A of X? The area, meaning the area of that cross-section. So in this case, it would be the area of a square. Other cases, it could be the area of a circle. Find the area of A of X, or the cross-section. And we know if it's a weird shape, we can find area by integrating, right? If it's not a nice geometric figure, you can do top minus bottom, find the area. Okay, 3, find the what? The limits of integration. And then this first step actually makes sense. Okay? What happens when we integrate a constant, like 2? So it increases the degree, yeah? Let's see. What happens when we integrate 2x? Increases the degree. So x squared divided by 2, that's gone. Plus c. So now we went from a constant to a linear to a quadratic, and then you increase the degree again every time you integrate, right? So if we're integrating area, which is 2-dimensional, we would then get cubic, which is volume, right? Which is 3-dimensional. So does that make sense? We get the volume by integrating the area. We get the area by integrating 1-dimensional lines or curves, right? Okay, so step 4 is integrate A of X to find volume. Okay, so on this one, it's being rotated around the x-axis. That's how it creates a 3-dimensional shape. So we sketch the solid. Let's find the area of any cross-section. Now the cross-sections are going to be changing sizes. So we have a square, because it tells us it's a square-based pyramid. What's the area of a square? What, Alex? You just said it. Right? Exactly. So our A of X is going to be length times width. But the length and width are always changing, but we know about if the length is X, the width is X. So our area, our A of X, we're going to be integrating A of X. Our area, in this case, is X squared. So that is 3 times 3 squared, because that's just the area of the cross-section at the very end. But anywhere along the pyramid in cross-section of X squared. Okay, now let's find the limits of integration. Since we're working around the x-axis, we can do it with respect to x. Because you can see there's just one nice little line. We don't have to do it with respect to y like we did the other day. So we're looking at the axis. It goes from 0 to 3, right? So the volume comes from integrating the area. So I think you can find the volume of that pyramid now by integrating x squared dx from 0 to 3. And make sure you have a unit with it, because I did tell you some information about the pyramid. What do we get when we get volume? Good, that's correct. He's cubing it, because, yeah, this should be up to cube, because it was squared, and you increased it to cube. Okay, what do you think? 1/3 times 3 cubed, right? Which becomes minus 0. Which becomes, you can do that without a calculator, right? 27 divided by 3 is 9. But volume means meters cubed. And we look how we increase when we're at squared. The square is two-dimensional, now we're cubed. Increase the power each time. Okay, one more on your line piece of paper. You can see what looks like in your book, because that's better than I can draw it. So example 2, without shooting to the next page, we have a region, a southern region, f of x equals 2 plus x cosine x, and the x-axis. Bounded by the interval from closed interval -2 to 2. You can see there the picture, better than I can actually draw it. But this, if you graph it with your calculator, you're really only getting the curve up there. And when we integrate this curve, we're just finding the area to the x-axis. We're just finding the area to the x-axis. So if we want the volume, we make it into 3 dimensions, which means we rotate it around the x-axis, and what shape does it form? Like a vase, exactly. So we get something like that, 3-dimensional now, vase. Now we're finding the whole volume, and it's not just this flat 2-dimensional vase-looking shape, it bulges out of the board as well and into the wall. Okay? So, first, draw a picture like we did. Second, look at the cross-section. Do we want to do a cross-section with respect to x or with respect to y? Yeah. And all the way through, I'm going to cut it. What type of shape are we getting? Good, a circle. Or a disc, right? Alright, where do you cut it? Actually, maybe I'll do it like this. Okay, so that's our area of x. What is the formula for area? Given any place, because you can see it gets wider and skinnier and wider again. What? Pi r squared. Okay? So to find the volume, we're going to integrate the area with respect to x. Okay, now area, what would that area be in this case? Pi is just a constant, right? Which actually we can, since it's a multiplier, we can pop the pi out in front. R squared. What is the radius on this base? It goes from the x-axis. Yeah, that's all right. So it's only half, since the full distance would be the diameter, right, of any of the cross sections. Okay, so this would be f of x, right? Because whenever you plug it in x, you get the height, which is f of x. Okay, so we have the radius is f of x. dx represents the width of that radius. Because volume isn't it pi r squared h? That h is going to be our width for the dx. So even the height is represented. Pi r squared h. And do we know what f of x is? F of x is, the function. So the easy part to forget is forget the pi. If you are only integrating the function, you're only finding the area. This is technically top minus bottom because minus 0, right, is the bottom of the radius. Top of the radius minus bottom of the radius dx. So what are our limits on the x's? -2 to +2. So this one you can use your calculator on. Okay, remember you go to F inch or whatever that abbreviation is on your calculator. Math number 9, Fn. Put in 2 plus x cosine x. You don't have to put a comma or minus 0. Comma x from lower to upper. That can kind of confuse you because when we do the math, we do upper minus lower. But when you type it in, it should be smaller first and then bigger. Okay? 2 plus x cosine x. Make sure you close these parentheses, comma x, comma -2, comma 2. Oh, you're right. The radius doesn't need to be squared. Good catch. This radius needs to be squared. Good catch. Good catch. Thank you. The whole function should be squared. Radius should be squared button. There we go. Now, if you just type this in, when you get your answer, make sure you times by pi. Or you could include pi inside. But pi is not part of your radius, so make sure the pi is not being squared. Okay, what do we get for the volume? Yeah, 52.4288. Okay, did you unit square? Yeah, because originally she was 16, so you're off by a factor of 2. I don't know why. Okay, we should have 52.4288. Volume, what's that unit? Units cubed. It doesn't tell you meters or inches or anything like that, so units cubed. Okay? Now that you have a basic idea, and you can see the picture on the book, which is a little better than my drawing. And look at that corner. So flip over to the one I handed you earlier. That looks like this. Now you should understand what the pictures are. We have a function y equals sine x from 0 to pi. So the sine curve, we should graph it first. The sine curve starts at 0, 0, right? Where is it at pi? What side of pi? 0. It's done half of its period by the time it gets to pi. And we've done the full up and down, and it gets to 2 pi. So this is pi. Okay? And then to find the volume, it means we're rotating around the x-axis. So we get kind of a morphed sphere, kind of, but it's not a perfect looking sphere. It's a little bit morphed. Okay? So, looks like we can still do respect to x. We did y, kind of weird. I think x will work nicely. Let's find the area. The area of a cross-section. What type of cross-section are we getting? They chop this up, right? Chopping up carrots. And you get a disc, a circle. Okay, and so we just discussed that. That's pi r squared. And the radius of any of our circles is what? The radius of any of our circles is f of x. Okay? So if we're doing volume, we're going to integrate a of x. Now that pi can go out front. The radius is f of x. dx represents the height, or really the width of the disk. So we have pi r squared h. So we're really finding volume, yeah? It's in the function while you're integrating. So the function here, yeah, we should put a square on that because f of x is just one radius. Okay, so volume equals pi times the radius, f of x. So it's sine x, it's really top minus bottom. And this, in a few problems, it's going to change. So get used to top minus bottom. The bottom is the x-axis, right? So minus 0, which for right now is a little redundant, square all that. But in a minute, it's going to be important that we know we're actually doing top minus bottom. So I'm going to put that over here so you remember. Top minus bottom squared. Okay? So what are our limits now? Zero to pi of dx. Okay, we learned the other day that sine squared involves using that double Euler formula. It's kind of awful. So let you use your calculator on this one. The next one we'll do by hand though. Okay, so integrate, make sure you square the sine and you times by pi. The pi isn't squared though. So if you are doing, using the pi inside on your calculator, you want to do pi first, and then sine of x, remember you put that in parentheses, square it, comma x, comma 0 to pi. Sine x, close parentheses after that, comma x, comma 0, comma pi. What'd you get for the volume? I need 4 decimal points. 0.9348. Volume equals that. We weren't given inches or anything, so I would just say units cubed. Always put a unit, even if they don't tell you a unit. At least write the word units cubed. Okay? Does that make sense? Now we're going to start changing it a little bit. The next one down, let's draw it. Okay, y equals minus x squared, which is the same as y equals negative x squared plus 4. Can anyone tell me how to draw that? Okay, tell me, Jake. Okay, vertical shift up 4. Downward parabola. So our first points are down 1, right, and left 1. And then the next points are down 4, right, and left 2. That's the ratio that most problems take. Or you can set it equal to 0 to find those x-intercepts. Okay? Actually, I'm not going to keep those arrows going all the way down through because next we have y equals 0. Is that a horizontal line or a vertical line? That's the x-axis. So that is our area that we're going to rotate and find the volume of. Okay, first of all, determine should we find the volume with respect to x or y. Yeah. X. X will work just fine on this one. Okay, so we're still getting a disk, a circular disk, right? So this is the top one with respect to the x-axis. The next one we're going to have some shifts. Okay, so what should come from the interval sign? Pi. Because the area, A of x, is pi r squared, right? Okay, and the volume we're looking for should have a pi r squared times h, and h is the dx. So now we need the radius. The radius of any of these cylindrical disks is top minus bottom. Top minus bottom. In this case, it's 0. So we have 4 minus x squared minus 0, and square the radius. Dx is the height of that little rectangle, which is really more for our eyesight purposes, the width of the rectangle. Okay, what are the limits of integration? With respect to x, so how far go off from the x-axis? Negative 2 to positive 2. Okay. We go find that volume. Math number 9. Don't forget that pi. The pi is not part of the squared radius. X, comma, negative 2 to 2. Oops, I made an issue. Oh. Charging your calculator. Push go to, and I'll tell you. And you also need, go to, you should use the square. You need the pi in front of all that. So it's my minus. Okay. So just go second entry. Okay, now do pi. Parenthesis, then the function. 4 minus x squared. There's an x squared button right here. Oops, I guess it's not just, I guess you do have to push the x and then the square. Okay, close the parenthesis and square again, because that's your radius squared. Comma, you put the x and then your limits. Did you get your sort? Okay, and you do the pi afterwards. Okay, so You can do it there. Okay. I'll push enter. I'll show you the same. Yep. Yeah. It's ancient technology. What? The radius. The top of the radius minus the bottom of the radius. So you're looking for the length of the radius. But you're looking for the length of the radius. This part is just the radius. Okay? So, yeah, this part right here, top minus bottom, is only the radius. So if we iterate, we get volume. I think we're all starting to get the same thing. 107.2330 units what? Cubed. Good. Okay. Now for the fun ones. Those are all been discs. Right? A frisbee disc. Any more than a frisbee disc? No. Okay, better not be here. Yeah. Oh, I erased the whole thing. Okay, I guess I'll have to do 1, 2, 3, 4. From -2 to 2. Okay. Alright. Actually, I'm going to take the wrong part off, because the second part, it says, we're no longer rotating, we're still bounded here, because it tells us it's getting. We're no longer rotating about the x-axis, but now we're going to rotate it around y equals -2. No way. So if we rotate around that, what type of shape are we going to get? It's going to be like a donut. There's going to be a hole in the middle. So if I take this, I don't even know what to call that, and rotate it around, it's going to be like a donut. So we're going to have a gap from 0 to -2 and a gap from -2 to -4 before we see the rest. And, yeah, imagine that as a donut. I can't really draw that. But maybe here, on page 406, like a butt cake. That's kind of what it looks like, right? A donut. And there's a hole in the middle. Just like a donut. So that's our parabola shape. This one's being rotated on the y-axis, but we like that. There. Okay, it's a donut. So we're going to find the volume of the donut, but we have to subtract out the hole, right? Okay, so now we look for the area. If we take a cross-section of our donut, we're no longer needing a circle or a disc, we need a washer. Okay? So gosh, I'm not very good at drawing these three-dimensional shapes. Okay, our washer has a certain width to it. It looks like a mini donut that's flat, right? Washers are flat. You know, like bolts and nuts and washers, like a tool set washer. Okay, it's still circular, but we have two different radii. We have the outer radii and the inner radii. Okay, so there's a width to this. If I can't draw three-dimensionally very well. This is hard for me. That's supposed to be the fun part. This is supposed to be the back part. Can you see that? No, we can't actually about any donuts. We have an activity that's kind of involving cutting, chocolate eggs. Okay, well, okay, but from the center, there is a smaller radius and a larger radius, which I'll do it this way, all the way out to the edge. That's big R. And the smaller radius is little r. The smaller goes to the inner part, obviously it's smaller. The big radius goes to the outer edge. Okay, so when we're finding our volume, it's similar. We have a pie So we're going to have the radius squared, big R, minus little r squared dx. Okay? So instead of just finding the area of one circle, we have two circles. We have the outer ring circle and the inner ring circle. That's not supposed to be inner. Okay? Outer minus the inner, so then it will say positive, right? Okay, so we need to find the outer radius. Well, the outer radius, let's get a different color, green. The outer radius, remember, still top minus bottom. Here is my center, because that's where I rotate around. If I go to the outer, what's my function? What's my function? Top minus bottom. This is the long big R. This is the quadratic function, is it not? Minus y equals -2 function. That's big R. So the quadratic, I can't see my quadratic anymore, so that's okay, is 4 minus x squared, that's the top, minus where I'm revolving around, which the bottom of that radius is -2. We'll square all that. The range of my donut is not that whole thing. It's only a partial segment. We need to subtract off the smaller radius, where the gap is. So the smaller radius is from here to here. That's where the gap is. Top minus bottom. What's the top? 0. Y equals 0. That was where our area was bounded at. Minus the bottom. -2. So we're subtracting off 0 minus the -2. And since that's another radius, make sure you square it. Dx. This is where it gets tricky. It's forming a disk. Okay, so we have pi integrated from, and we're doing this with respect to x, so it's still our -2 to +2 of 4 minus x squared plus 4, not plus 4, plus 2, plus 2 squared, that's the long radius, minus, let's see, yeah, +2 squared, dx. And if you want to do the math to simplify that, you can, just be careful, or you can just type that into the calculator. Okay? Don't forget about the pi. Pi and then f int. Make sure you use parentheses because that first group is all being squared. Close it up and square it before you subtract the 2 squared. Close out with parentheses, comma x, comma -2 to 2. If you have the old version. Oops, it says. If you mess up like I did, it says error argument quit or go to. You can go to the go to and then the blink on what you messed up on. That shouldn't be a problem. I'll just change it to 4. Still doesn't like it. 4 minus x squared plus 2 squared. Oh, I better know what it is. Ah, okay. What do you guys get? Yeah, okay, it's parentheses. Because I was having a hard time with parentheses for a while as well. So you have it. Minus 4. Oh, comma x. You need second insert. Oh, we already have a comma. X, second insert, comma. Now push enter. Talk a little bit. I have 241. Okay, your pi is going to be times to everything. So I'm going to put that pi in front of the Fn because it is times to everything. That's how this works. Okay, your pi is going to be times to this first one. Okay, so you put the pi in front of the Fn. And you should be getting 241.2743 units cubed. Okay. Let's go over number 4 if you have time and go back to the one about the 5. So let's go over number 4. Okay, this one says y cubed. So cubic kind of looks like that. Y equals 0. So that's the x-axis. And x equals 2. 1, 2. So it's that area. We're first rotating about. The first one we're rotating about x equals 2. Okay, rotating about x equals 2. So that means we're rotating horizontally, right? Okay. So we'll get something like, it looks like the Eiffel Tower in 3D being rotated around. Or like a megaphone. Okay? Now each cross section this time is going horizontally, right? So this one's with respect to y. So circles, is this going to be a washer or a disc? This is like a frisbee with no holes. Washer has a hole with a donut. So it's a disc, so a little easier. So we know volume, the integrating area. And what's our A of x in this case for a disc? What shape is going to be? Simple, so it's just pi r squared. So the pi has to multiply by everything. R squared is the radius. Now the radius is only half of what I do. The radius is from there to there. Top minus bottom usually, but in this case, since we're doing with respect to y, it's right minus left. The right minus the left, all squared. Right minus left, all squared, dy. Okay, what functions on the right side? Oh, actually, on the other one. Let's do it on the one that we actually have. The function on the right side is y equals 2, or x equals 2. Okay, but we do have a problem there. With x equals 2, what's with respect to y? Or is that okay? And this one is on the left, correct? Okay, so right minus left, we have pi integrating 2 minus what? Yeah, cube root of y. Why does it have to be the cube root of y? So we have to respect to y. If we solve this one, we have to cube root the x, or both sides, and then get cube root of y equals x. So that's why we can leave this one here, because it's got x equals. And this one's got x equals. Okay? Make sure you square all that before you integrate. What are our bounds? We should be looking for the y's. From 0 to, where do those two intersect? Or how can we find out where they intersect? So we know 2 equals cube root of y. So how do we solve for the y where they intersect? Cube. So 2 cubed would give us our answer. What is 2 cubed? 8. So our bounds have to be in with respect to y from 0 to 8. Okay, let's practice putting this one into our calculator. I would do the pi first, so that we make sure we're trying to pi to everything, so we're struggling on that little pi. F int, and type in your function. 2 minus cube root. You know how to go into the math function and get cube root? Y, well, our calculator is going to be an x, comma, 0 to 8. Second, pi, math number 9. 2 minus, we go to the math feature, the cube root is number 4. X, close the parentheses, comma, x, comma, 0, comma, 8. Yeah, all squared. Yeah. All of that squared. We're slow at integrating. That's a lot of thought for the calculator. The processing. Oh, there we go. What did you guys get? 10.053. Okay, let's see here. 4 is a, oh, it's not that it's a 2. Right, 2 minus 3 squared. So right now what you're squared is you're only squaring the cube root. So you need to make sure all of that is in parentheses. So second enter. And then just you need a parenthesis in front of 2, so second insert. Blue insert, parenthesis. So you can group the whole thing and then put the blinking bar on the square. Second insert. Parenthesis. Okay, so that whole group is being squared. Now push enter. I think you're okay now. Mine took a while to process. Okay, yep, 10.053. Yes, or you can do a 1. Go around. Okay, Alex, can I answer your question really quickly on the homework?